Hi everyone! Today let's talk about session 9.2, Properties of Power Series. Big idea. Series involving a variable raised to a power are called power series. They're extremely useful as an alternative way to represent any function. Since their computation involves only addition, subtraction, and multiplication, so it's much easier to compute the power series rather than the function. Big skills. You should be able to compute the interval of convergence of a given power series, to differentiate and integrate a power series term by term, and to obtain power series representation of a few basic functions related to the geometric power series. Okay, so we call for the geometric series. We have the series r to the k equals to, so when we plug in k equals to 0, we get r to the 0 is 1. And when we plug in k is 1, we get r. So this series is like 1 plus r squared plus dot dot dot. And we remember this geometric series converges if the absolute value of the ratio is less than 1. And when it converges to the first term. Okay, so if absolute value of r less than 1, then the series converges to the first term over 1 minus the ratio r. Okay, and if the absolute value of r greater or equal to 1, the series diverges. Okay, so here our first term is 1, so 1 over 1 minus r. So this is the geometric series. Now, let's replace r by x. Then we get the power series. Okay, so power series is a series containing x, the variable x. Now, the power series becomes a representation of a function. See, this is the function it represents. So here we have the power series, and here is the function. The power series converge to the function provided the absolute value of x is less than 1. Okay, so notice that the function y equals to 1 over 1 minus x is defined for x where x not equal to 1. And its power series converges for the absolute value of x less than 1. Okay, so we can see if I draw a picture, this is 0 and this is 1. So the function is defined for x not equal to 1, and the power series converge for the absolute value is less than 1. So which means it converges in this region. So far so good. The set of values for which a power series converges is called its interval of convergence. So this guy, in our example, our interval of convergence is -1 to 1. Okay, so for the remaining of this chapter, I want you to focus on the two concepts: the power series and a function. Okay. Given the power series, how do you find a function that it represents? Given a function, how can you find the power series represent that function? So this is a two direction. Okay. And even though you find the power series that represent that function, it's not always converge to that function. Sometimes maybe on some x values, the power series converge to the function. Maybe on some other x values, it diverges. Okay, so that's why the x values on which the power series converges to the function is called the interval of convergence. Okay, so the x values on which the power series converge to the function, let me draw the So this is called the interval of convergence. Okay? So in the remaining of this chapter, we're going to talk about more about the relationship between the power series and the functions it represents. Okay, so definition, we call definition. A power series has the general term. We have the coefficient times x minus a to the power of k, where a and ck are real numbers, and x is the variable. The ck are called the coefficients of the power series, and a is called the center of the power series. The set of values for which the power series converges is the interval of convergence. Okay, so A is the center, and the interval of convergence is maybe like right here. Okay, the radius of convergence of the power series denoted by r is the distance from the center of the series to the boundary of the interval of convergence. Okay, so this is r. Then this number is a minus r. This number is a plus r. So your center is a, is always in the middle. Oh, let me make it look better. So your a is always in the middle, and then your interval of convergence is from a minus r to a plus r. Sometimes you might include the endpoint, and sometimes you might exclude the endpoints. It really depends on whether the series converges at the endpoints. And then the radius of the convergence is the distance from the center to the boundary of the endpoint of the interval of convergence. Okay? So convergence of power series. A power series centered at A converges in one of the three ways. First, the series converges absolutely for all x, in which case the interval of convergence is all real numbers minus infinity to infinity, so the radius of convergence is infinity. Okay, that's the first case, all real numbers. Okay, second case, there is a real number r greater than 0, such that the series converges absolutely for when the distance between x and a is less than r, and diverges for when the distance of x and a greater than r. It means we have the case. Okay, so r is a number. Okay, so we have the case a, and we can have the case here a minus r, a plus r. Okay, so our series converges when x lies in this interval, or we can have maybe the left endpoints. It converges at the left endpoint, and maybe it diverges on the right endpoint. So you can have this guy is a bracket, and on the right is a parentheses, or we can have the left guy is a we don't have like convergence at the left endpoint, but we converges at the right endpoint, or we converge on both of the endpoints. So actually you can have this 4 subcases. Okay, so we know the series converges when x lies in the interval, and it diverges when x lies outside of the interval. Okay, so this is the second case. The third case, the series converges only at A, the center, in which case the radius of convergence is 0. Okay, by the way, it always converges at the center. Why? Because when you plug in A is 0, when you plug in x as a, what happened? A minus a is 0. So this guy, the series, just 0. So 0, of course, converges to 0, right? So that's why all the series converge at the center. Okay, and this guy means the series converge only at the center. So that's why here, if we draw the picture, it only converges at A. It diverges anywhere, okay? So that's why the R is 0. So far, so good, everybody? Okay, so those are the 3 cases. And now it's time to look at examples. Okay, so I'm gonna separate into steps so you can follow the steps. Okay, so what is the first step? Well, the first step, You want to figure out the center? So what's the center in this case? Well, center is if you have x minus a to the k, then your center is a, right? So here you see x to the 2k, then it's like x minus 0 to the 2k. So center is 0. So far, so good? Okay, and next, so we call that in chapter 8 we have many tests. We have divergence test, we have integral test, we have ratio test, root test, and limit comparison test, and alternating series test, right? So we have so many tests to choose depending on the series, okay? But in chapter 9 we only do one test. That is the ratio test. Okay, so only use the ratio test. So use ratio test. Then R is the limits. K goes infinity. A sub k plus 1 over a sub k. So a sub k plus 1 is, we replace k by k plus 1. So x 2k plus 1, 3k plus 1, and other parentheses. So here, don't forget the parentheses. And then a sub k is, we just copy it down. By the way, this guy is our ak. So 3k factorial. And because all the terms are positive, we don't need the absolute value. And remember, next step, we're gonna split. Okay, split. How do we split the top? Well, this is like x to the 2k plus 2, right? So you split as x to the 2k and x squared. The bottom is like 3k. So let me write it down here so that you can see. So this guy is like x to the 2k plus 2 over 3k plus 3 factorial. Okay? So let's continue. So 3k plus 3 factorial, that is 3k plus 3, 3k plus 2, 3k plus 1. 3k, good, because we use the 3k in the denominator, so we can stop right here. And then x to the 2k, we put it down, and 3k factorial, we put it up on top. Okay, so this is what we get. And then we can simplify it. How can we simplify? We cancel this guy, and we cancel this guy. Okay, what's left? So we have x squared. Oh, by the way, x could be negative. X could be negative. So that's why when we talk about x, it's better to put an absolute value around it. Even though like x squared always positive, but in general, when you have the absolute value, is your x can be negative. So move the absolute value around the x. Okay, and then the denominator, we have 3k plus 3, 3k plus 2, 3k plus 1. Okay, so this is the limit about k. This is not the limit about x. So when k goes to infinity, well, your x is like a constant. So constant over something goes to infinity. What's the answer? 0. Yes, r is 0 no matter what the x is. Okay, but the ratio test, if the r is less than 1, so 0 is of course less than 1, then the series converges, right? Actually, it converges for all x. You see, no matter what the x is, our ratio r is always 0. Okay, then by the ratio test, the series converges for all x. For all x means, what is the interval of convergence? Yes, minus infinity to infinity. What's the radius of convergence? Infinity. Okay, so that is part A. Let's continue to look at part B. Ooh, this problem looked more complicated, so more interesting. So what is the first step? Center. Our center is, can you tell me what the center is? X minus 2, so the center is 2. Okay, second step, which test do we use? There's only one test we use, ratio test. So R is limit AK plus 1, AK. What is AK plus 1? Well, you can see we place all the K by K plus 1. Well, but we know that we have absolute value. So absolute value of -1 is just 1. Okay, and then we have x minus 2 absolute value, and then to the power of k plus 1. And then 4 to the power k plus 1. The square root of k plus 1. Okay, so when we plug in k, is the thing, right? But absolute value of that, we have x minus 2 to the k, 4 to the k, square root of k. Okay, next we're gonna put down those. So x minus 2 to the k plus 1, how do we split? We can split as x minus 2 to the k and x minus 2, right? Why do we want to split it? Because we want to cancel the terms in the AK. And 4 to the k plus 1, we can split it as 4 to the k and the 4. Well, square root of k plus 1, just leave it like that. By the way, don't do this. It's not equal to square root of k plus square root of 1. No. So don't do that. And then we have x minus 2 to the k is downstairs because a over b over c over d is a over b times d over c. So the c actually stay downstairs. And the 4 to the k is like the d is upstairs and the square root of k. What can we cancel? Well, we can cancel x minus 2 to the k. We can cancel 4 to the k. And that's it, right? So let's continue. Okay, so here you can see x minus 2, it has no k in it. So it's like a constant, right? For the constant, we can move it outside of the limit. So x minus 2, and then we have the limit k goes to infinity, square root of k, and 4 square root of k plus 1. Okay, when k goes to infinity, what's the dominant term of the numerator? Square root of k. What's dominant term of denominator? 4 times square root of k, right? So that's why we have x minus 2, and then limit square root of k, 4 square root of k. Remember, I can allow you to do this like shortcuts way, but you have to promise that you will write dominant term of the numerator and dominant terms of the denominator. Then they cancel, so the answer is x minus 2 over 4. Okay, so we know by the ratio test, series converges if our ratio is less than 1. Okay, and it diverges if the ratio that is greater than 1. Okay, so keep that in mind. So let's find where the points that it converges. So this got less than 1. Let's multiply by 4 on both sides. Okay, so we get that. Okay, how do we solve this? Well, let me recall you. X absolute value of a, x less than a, that's the same as x less than a and greater than minus a. Okay, well, why is that? Think about it. You have 0. Okay, x is like absolute value of x is like the distance from x and the origin 0. The distance from x to 0 is small. You see, a small. The distance is small, so it lies within it. Okay, so how about if distance is big? Well, if this is big, then it's like outside of it. So x greater than a or x less than minus a. Okay, so keep this in mind. So in our case, we have x minus 2 bounded between 4 and minus 4. And then we add 2 on both sides. So negative 2 less than x less than 6. Okay, so series converges on those values. However, remember the ratio test. So ratio test is inconclusive when the r equals to 1. So that's why you gotta check the endpoints. Okay, so that's why we gotta check the endpoints. We cannot stop here. We cannot stop here and say, oh, the interval convergence is this guy. No, we haven't checked the endpoints. So last step, check endpoints. The last problem, we didn't check the endpoints because it converges for all real numbers. So there's no endpoint for it. But here we gotta check the endpoints. So what are the endpoints? Well, the endpoints are 6 and negative 2. I suggest you to check the positive number first and then check the negative number. Okay, so check 6. 6 means we plug 6 into our function, okay, series. So when we plug in 6, what happened? Six minus 2 is 4. So 4 to the k over 4 to the k square root of k. So far, so good, everybody. Oh, you can see I can cancel 4 to the k. Then I have minus 1 to the k over square root of k. Okay, so now what happened? This is an alternating series, right? Alternating series. We use the alternating series test. So what is the alternating series test? Two conditions. Is the limit of the sequence 0? Is the sequence decreasing? So the sequence here is 1 over square root of k. Yes, the limit of 1 over square root of k is 0. And 1 over square root of k is decreasing. Yes, by the alternating series test, this guy converges. So far, so good, everybody. And how about on the other hand, when x equals to negative 2, x equals to negative 2, well, negative 2 minus 2 is negative 4. So we have negative 4 to the k, 4 to the k, square root of k. Okay, you can actually split. You can split this as negative 1 to the k and 4 to the k over 4 to the k. Well, negative 1 to the k and negative 1 to the k actually cancel. Why is that? Because you combine, you get negative 1 to the 2k. Well, negative 1 to the 2k is like negative 1 squared, which is 1. 1 to the k is 1. Okay, and then 4 to the k and 4 to the k cancel. So this is the series of 1 over square root of k. Well, this is a p series, okay? What's the p? K to the 1/2, right? 1/2 is less than 1. Remember, for p series, if the p is less than or equal to 1, the series diverges. Okay, let me write it down here in case you forgot. So the p series converges if p greater than 1, diverges if p less than or equal to 1. Okay, so that's why, at the point 6, it converges. At negative 2, it diverges. So finally, interval of convergence is, do we include negative 2? No. Do we include 6? Yes. So actually, we have one of the endpoints, but not the other one. And what is R? Let's draw a picture. What's the center? The center is 2, right? Yeah, center is 2. And then minus 2 is here, 6 is there. What's the difference? That's 4, right? So the radius is 4. Radius of convergence is 4. So you can always draw the picture and then help you to understand. Okay, we have the center, which is 2, and then the interval of convergence from minus 2 to 6. So the radius of convergence is 4. Okay, so now we see this is the example of like case 2. Remember first case, we have the interval of convergence is all real numbers minus infinity to infinity. Case 2, we actually have an interval, but however, whether it converges at the endpoints really depends on the series. Okay, so this is one of the case of that second case. Okay, one of the example of that second case. The third case is when the series only converges at the center, only one point. It diverges otherwise. Okay, anywhere else. Okay, so let's look at part C. First steps, what is the center? The center is 0, right? Second steps, we use ratio test. So R is limits, k goes to infinity, a sub k plus 1, a sub k. Okay, what happened? A sub k plus 1, well, we plug in k by k plus 1. And x become absolute of x to the k plus 1. Okay, and k factorial x absolute of x to the k. Alright, let's split and cancel. How do we split k plus 1 factorial? Well, that's k plus 1 and then k factorial. How do we split absolute value of x to the k plus 1? We split as absolute value of x to the k and absolute value of x. And then the bottom we have k factorial absolute value of x to the k. Okay, cancel this guy, cancel that guy. Well, our answer is k plus 1 times absolute value of x. Well, you can see this guy. If x is 0, this limits is 0. But if x is not 0, what happened? Well, this limits. See, if x is not 0, k goes to infinity. It goes to infinity. So that means the series diverges if x not equal to 0. So that's why series only converges at x equal to 0. So our interval of convergence is a single point. So it's not an interval, it's a single point. How do you denote a single point? Well, we use set to denote. So a set containing only one point. And what is the radius of convergence? 0. Okay, so this is an example of the third case. We only converges at the center. So now we have seen example of all 3 cases. So I hope that you can pause the video and work on this problem on your own. Are you done? Let's check our answer together. So first, we compute the center. What's the center? So x minus 5, right? So the center is 5. So it's like you set this guy equal to 0 and then you solve for x. So this is how you get it, right? This is how we find the center. Second, we use ratio test. R is the limit k goes to infinity. And a sub k plus 1 over a sub k. Okay, what is that? Okay, so that is the limit a sub k plus 1 means whenever you see k, we place it by k plus 1. And then here, the absolute value, make this be absolute value of x minus 5 to the k plus 1. And here we have k plus 1 squared over the denominator x minus 5 to the k and k squared. Alright, let's split. So we split this as x minus 5 to the k and x minus 5. And then the denominator, oh, we're not able to split it, so just leave it like that. And then x minus 5 to the k is downstairs, k squared is upstairs. So we cancel this one. Okay, so now you see that the absolute value of x minus 5 is like a constant. We can move it outside of the limit. Then we have k squared over k plus 1 squared. Okay, what's the dominant term of the numerator? So dominant term of numerator, there's only one term, k squared. How about dominant term of denominator? Also k squared. So when k equals to infinity, they actually cancel. So we just get x minus 5. Alright, so and then by the ratio test, series converges if the ratio is less than 1, okay? It diverges when the ratio greater than 1, okay? So let's see, x minus 5 less than 1, that means x minus 5 is distant small, right? Less than distant small. Small means bounded by 1 and minus 1. So this is how I think. Distance is small, then it's bounded by the number. What are the numbers? 1 and minus 1, okay? If distance big, okay, greater than, then is either less than minus a or greater than a, okay? And then we add 5 on each of the term. 5 minus 1, 4. 5 plus 1, 6. Okay, so remember the series converges when x is greater than 4 and less than 6, but at the end point, the convergence test tells us nothing. So the third step, we also need to check the end points. So at x equals to 6, at x equals to 4. At 6, what happened? At 6, 6 minus 5 is 1. 1 to the k is 1. Okay? At 4, what happened? 4 minus 5, negative 1. Negative 1 to the k. Okay? So, you realize at the endpoint, you get, when you plug in the endpoint, you will get one of the series is like the alternating series of the other one. Okay, you just have one of the series has an extra factor of minus 1 to the k. Okay, that's always the case. That's why it's good to figure out the series of the positive terms. Okay, because if this guy converges, then the alternate series also converges. Why? Because we have the absolute convergence implies convergence. Okay, so that's why I suggest that you can work on the series of positive terms. Okay, if it converges, then so we're using absolute convergence. If this guy converges, implies convergence. Okay, and so here, I mean the AK could be negative, okay? And, yes, if this guy diverges, then you can see, okay? So see whether you can apply the alternating series test for the alternating series. Okay, so this guy, this is a P series with P equals to 2. Well, 2 greater than 1, so this guy converges. Yay! If it converges, then this series also converges. See, you don't even need to use the alternating series test. So that's why when you get those, you compare, okay, which one is the positive terms, and then you figure out that first. If that converges, the alternate series automatically converges. If that If this guy diverges, then you can use the alternating series to test to determine whether the alternating series converges. Okay, so what is the interval of convergence? Let's draw a picture. Center is 5, 4, and 6. And at 4 and 6, they also converges. So that's why here is 4 and 6 include the endpoints. And the radius of convergence is, what's the difference between them? 1. Okay, everybody? Yes, so we also have the case 2, right? Case 2, we actually have an interval. But in this case, the series converges at both of the endpoints. All right. So again, please pause the video and try this problem on your own first. Are you done? Let's check our answer together. So what's the center? Well, you look at this factor, 4x minus 8, you make it equal to 0. Then what is x? So we solve for x. X is 2. So the center is 2. So far, so good, everybody? Second, use ratio test. Okay, ratio test R is limits k goes to infinity, a sub k plus 1 over a sub k. A sub k plus 1 is whenever you see k, replace that by k plus 1, and for the x term, give it an absolute value. Okay, a sub k is just what we have, but put an absolute value around the x factor. Alright. See, you can see the steps are very, very similar. So let's split. 2 to the k plus 1, let's split as 2 to the k and 2. 4x minus a, let's split as k and a single term. K plus 1 cannot split, just leave it like that. 2 to the k is downstairs. 4x minus a to the k downstairs. And k upstairs. Okay? So now let's cancel. So we can cancel this guy and we can cancel that guy. Okay. What do we get? Okay, so because x is like a constant, right? So we can move the x outside of the limit. Then what's left? We have 2k on the top. We have k plus 1 at the bottom. So what are the dominant terms? Well, the dominant terms are 2k and the k, right? So that is why here we have 4x minus 8 and 2k over k, that's 2. Okay, so this is the ratio. Series converges if our ratio, which is 4x minus 8 times 2, is less than 1. Okay, let's solve for it. So we both divided by 2. And then we get rid of the absolute value. So this is small. You will see, because r less than 1, you always get a small distance. So that's why it's always bounded between the numbers. Okay, and then we add 8 on each of the term. 8 minus 1/2. 8 is like 16 over 2. 16 minus 1, 15 over 2. 1/2 plus 8. 16 plus 1, 17 over 2. And then what's x? So x is divided by 4, 15 over 8, and 17 over 8. Okay? The third step, we gotta check endpoints. So what are the endpoints? We have 17 over 8 and 15 over 8. 17 over 8. Okay, let's put it in. Okay. 4 times 17 over 8 minus 8 to the power of k over k. Okay, and then the other one, 2 to the k, 4 minus 15 over 8 minus 8 to the k and to the k over k. Okay, yes, I would like to work on them together because I want to see which one gives me the positive one, and then I can determine whether that guy converges or diverges first. Okay, so 4, 8 cancel. That's like 17 over 2. 17 over 2 minus 8. So that's 1/2, right? So we get 2 to the k, 1/2 to the k. Oh, what happened? They cancel out. We just get the series of 1 over k. This guy, 4 and 8 cancel. So 15 over 2 minus 16 over 2 is negative 1/2 to the k. Wow, 2 and 2 cancel. But you still have the factor of minus 1 to the k there. See? Here is the series of the positive terms. Here is the alternating series. Then we figure out this guy first. This guy is the p series when p equals to 1. We know by the p test, this guy diverges. Right? Diverges when p greater than 1, it converges. When p less than or equal to 1, diverges. Okay, if this guy diverges, well, then for this guy, we gotta use the alternating series test. Okay, you can see the limits of 1 over k is 0 and 1 over k is decreasing. So that's why by the alternating series test, this guy converges. Oh. So what is the interval of convergence? Do we include the 15 over 8? Yes. Do we include the 16 over 8? No. How about the radius? Well, let's draw a picture. Center was the center. 2, right? And then here we have 15 over 8. And here we have 17 over 8. Wait, what's the difference between them? So 2 is like 16 over 8. So the difference is 1 over 8. So the radius is 1 over 8. So far, so good, everybody? Do you have the same answer? Okay, great. Okay, so let's continue in video part B.